Hello. Hello. Welcome back to another day of coding challenges. Another day of learning. Another day of trying. So I did figure out that I was a little off yesterday. Definitely had a little bit of a fever overnight. Definitely feeling it a little bit today. Sweaty and congesty. Hope you all are doing great. Hope that you are able to maintain focus and, get the things that you've been wanting to get done. I need Sorry guys. Take me a little bit of a second here to get set up. Bear with me. We got some challenges today that are kind of just redos of challenges from yesterday. But nonetheless, it's time to get pretty stumped on these challenges, that's for sure. Is that testing anxiety? Anybody else have testing anxiety? There we go. All right. Let's see here. Where are we at? Why is this one not done? Let's make some variables. Declare a variable named my number. Like, I kind of almost want to skip past them because, like, we've already done those, and then, like, if I submit them, they will. If I resubmit those, they will count against my daily submits. Where's my mom's at? I don't have either one of my moms today. We all knew there was a challenge rehearsal coming. We all knew. Where's my mom's? I don't have a single one. It's okay. I know you both are probably busy. Busybodies, busy bees. Alright. Let me reset my avatar's position here. Okay. Alright, so for some of you that were here yesterday, you know that we did something like this already. I really struggled. I'm probably going to struggle again. We're going to try our best, as always, to, not use the hints, really try and think it out. So today's challenge is you are given two arrays, array 1 and array 2. Your job is to find the union of those two arrays. For example, the union of array with 1, 2, and 3 and 100, 2, 1, and 10 is 1, 2, 3, 110. Basically, your job is to create a new third array and store every different number from both arrays. Make sure not to have duplicates. Looping through the arrays and using the includes method might help you. So we know that we're going to do 2 loops, that we're going to have a third array, and yeah. Alright, so we're going to start with a for loop. And I think we're just going to start small as well, just like we typically do. And then I also need to pause my screen for a second because I need to pull up the compiler. So just like before, we're just going to make sure that we have as close to the correct answer as possible. Make sure that down here we have our function. With array 1, array 2 as our arguments there. And then we're also going to let array 1 equal. Is listening to Final Fantasy Lo-Fi live every day, all the time. It's a little repetitive though. Little repetitive. Okay. So math this out here. So we have an array 3 declared. Alright, and then for let I equal arrays dot length, if I is less than array 1, add 1 to I. If array 1 index or if array 1 does not include array 2 index, then array 3, push, array 2. Then console. No, don't do it in the loop. Console log, array 3. What do we get here? Nothing. We're gonna get stuck here again. I know for a fact we're gonna be stuck here for a little bit. Include the... I equals 0. If I is less than array 1. Okay, hold up. What did we just get here? 1, 1, 1, 1, 1 and 7. So we got 4 1s and a 7. Interesting. At least we have a response. I don't understand the response, but at least we do have one in general. Alright. We're gonna cheat sheet a little bit on this one. Didn't matter. Wanacus! How's the thing? It's horrible so far. I'm stuck on the same challenge that we had yesterday. I'm stuck again. And I think I'm just overthinking it again. As I was yesterday.
Quanticus. What kind of challenge? What ails ye?
What ails ya? So it's the one where we had to loop over array 1 and array 2 and create a for loop to make sure that there were no duplicates. And my brain is having a hard time understanding for loops entirely now. I think we focused too long on for loops and it's now breaking my brain.
Quanticus. Your check-in for dups in ARR1 instead of ARR3.
Okay, you're checking for dupes in ARR1 instead of ARR3.
Quanticus.
And you're looping through array 1 while checking the elements of array 2. Okay, alright, slow down. Slow down. I know I'm always doing something wrong. Alright, we're checking for dupes in array 1 instead of array 3. If array 3 does not include array 2's index. And you're looping through array 1 while checking the elements of array 2. Oh, you cookie. Okay, so we ended up with 2536 after the loops. You smart cookie, you. Alright, and then for let j equal 0, I is less than array 2's length. And I'm doing I again. J. I'll get this eventually. If array 3 does not include array 2's index, then and only then are we going to push into array 3. Okay.
Quanticus. You can do I if you want, since they're separate loops. If one loop was inside the other, you'd have to use j or some other variable than I.
Oh, okay. Alright, my bad. Alright. So, just for my own future reference, or anybody that references these videos, so Quanticus did let us know you can do I if you want to, since they're separate loops. If one loop was inside of the other, you'd have to use j or some other variable. And that is true, and I didn't even think about that. So because it's outside of the scope of the other for loop, it's technically undefined. Yeah? So I didn't even think about that. That is very true. Although, I can't be having this. I can't be mixing the two now. There we go. Alright, and then console log array 3. 2, 5, 3, 6, 1, and 7. Alright, if it wasn't for Quanticus, we wouldn't have resolved this again. So thank you, Quanticus, for all of your amazing help that you honestly helped me through here. Alright. So part of the learning curve is showing, but part of the understanding is improving, if that makes sense. Looks like we're about to learn something new that I know nothing about. Come on, phone. I wish I knew people that know how to solder wires. That'd be super awesome. I gotta... There we go. Now my notifications are working on my phone. We heard that. Okay. But yeah, I wish I knew somebody that does soldering of wires, because me and solder don't get along. I got a charger that you gotta hold at a certain angle to get the wires to touch. IIFEs. Let's talk about what we can do with function expressions. Immediately invoked function expressions are something you might come across while programming. As the name suggests, there is a function expression that gets invoked immediately when it is declared without having to call it. Syntax looks like this. A open parenthesis, we're going to put the function inside of it. Really? Really? That's a thing?
Quanticus. I can't imagine you'd use this very much at all for the time being.
Is that right? Is that how it was done? No. This was at the end, yeah? I've never seen that before. I can't imagine you use this very much at all for the time being. Is it something used more in production? To explain the syntax, we'll start from the inside out. The main part of the IIFE is the anonymous function. We write an anonymous function first with whatever code we want inside. Then we wrap the anonymous function in parentheses. We write the parentheses next to the parentheses containing the anonymous function in order to call the function and make it execute the code. We can store the return value in a variable. For example, const greeting equals function, return hello. We don't have to wrap the anonymous function in parentheses. If we do this, this function runs once without us having to call it, and the value of greeting becomes hello. Okay. We can pass parameters like this: function, app inversion, console log, running app, call app, version, call version. And then in parentheses, we can actually pass the parentheses at the end. We can pass in Flappy Bird in 5. Running app Flappy Bird version 5. We might use IIFEs for multiple reasons: to avoid polluting the global namespace, executing async functions, using them in design patterns, and more. These concepts might not sound familiar to you, but we'll cover some of them soon. Do not worry about them for now. Then don't tell me about them. Arrow functions. So, from what I've seen about like multiple other websites of doing this, you know, going through my boot camp, if it keeps going at the rate that it's going right now, this would be considered more of the advanced fundamentals. At least from everything that I have ran into. When you run into arrow functions, if it keeps going past that point, it's usually from there you're in the, you know, the more advanced section. Arrow functions are great. I don't know if you've noticed something about me yet, Quanticus, when we're doing functions over on the online JavaScript compiler. There's a very big reason I don't use arrow functions. A very big reason. And it's not that it's wrong to use arrow functions, by the way, just in case if anybody's, you know, hearing me say that and be like, well, you know, we use arrow functions all the time. They're, you know, they do this, that, blah, 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 blah. And like, I personally don't like arrow functions. Arrow function expressions are an alternative to regular function expressions. They were introduced in the ES6 version of JavaScript. There are minor differences between arrow function expressions and regular function expressions. The main difference is in the syntax. This is what an arrow function expression looks like. So we start with parentheses, put in parameter 1, 2, and then arrow and curly brackets. I did try and make an arrow function the other day before starting. So, you know, at least my brain is trying to get used to new things. So it is similar to a regular function expression with some differences. They are useful for when you need to pass a function into another function. Oh, true. So so if you're passing a function into another one, would you put it in the, you know, like the arguments? So it is similar to a regular function expression with some differences. We remove the function keyword and we add an arrow between the parentheses.
Yeah, put the entire array function inside the arguments.
I put the entire array function inside of the arguments. Oh, gotcha. I'm always down. By the way, Quanticus, if you like want in the Discord, like want to come into the Discord and, you know, like share some like coding stuff and be like, you know, hey, like this is an example of what I do with this. And like, I'm always down for that. We don't have a whole lot of, you know, people that are coding in our Discord. We have mostly games because that's what I did for years, is just games on the stream. But we got a few people that are interested in coding or like wanting to start it in the future. So you can always feel free, hop on our Discord, you know, share some stuff. That is always an option. And I'm always down to talk about code. Like, as you can see, I'm not the smartest cookie, but I'm always willing to at least try and understand what's going on. For example, const greet equals function, and then we put in our curly brackets console log hello. So that's how you would normally do it. With an arrow function, const greet equal. We don't have any params to pass in, so we just start our arrow function, and in curlies we put console log hello. We can use parameters as well. Const sum equals num1 num2 into an arrow function, curly brackets return num1 plus num2. Now, one of the powers of arrow functions is that we can make them much shorter than regular functions. Let's look at this. Const squared equals num, arrow function, curly brackets, return num times num. If the code inside an arrow function is only one line, we can completely remove the curly brackets. The above code becomes const squared equals num into an arrow function, return num times num. If an arrow function only has one parameter, we can remove the parentheses as well. The above code becomes const squared equals num arrow function, return num times num. If an arrow function has only one line with a return statement, we can get rid of the return. Wow, okay. We can get rid of the return only if we got rid of the curly braces as well. The above code becomes const squared equals num arrow function num times num. If you have two or more parameters, we still have to use parentheses. Const sum equals num1, num2 in parentheses because, you know, we're passing in two parameters. And we start our arrow function of num1 plus num2. Wow. I didn't realize how much you can actually knock off of the arrow function. That's pretty neat. Turn the following function declarations and function expressions into the shortest versions of arrow functions possible. Make sure to turn the function declarations into expressions. Okay. So calculate. Going to be const calculate. Here's our params. Here's our arrow. Return num1 times num2 plus num1 minus num2. It would help if I put my equal sign in there. Just like I said, I didn't realize how much you can knock off, so I'm gonna want to make sure that I double check everything here, make sure that it can't go any shorter. So because it has two params, we need to keep the parentheses. An arrow function has only one line with a return statement. So technically, we don't even need a return. So const print info equals we have no args, so we don't need parentheses, right? Or am I misunderstanding?
You have to remove the if you remove the return.
You have to remove the curly brackets if you... Okay. If we remove the return. Okay.
Provided as nuts.
Yo,
So
nuts!
you single smirking face.
My single? No. No nuts. But welcome. Welcome. If an arrow function has only one parameter, we can remove the parenthesis. If the code inside an arrow function is only one line. Okay, so it has to have a parameter and only one parameter if we're going to
Provided as nuts.
do that.
I thought it was my chance, finally, loudly crying face.
I thought it was my chance, finally. Sorry, nuts. You can always be my smite wifey, though. That's always allowed. I don't think we can shorten this one any more than we already have.
Provided as nuts.
Let's go.
Let's
we
go.
still
We
haven't
still
played.
haven't
I
played
know.
Face with Tears of
No,
Joy.
I haven't. So when you got me Smite 2, I think I was only like computerized for like 2 or 3 weeks after that. And yeah, and then plus you disappeared too. So it's not just my fault. I'm always down. I don't think we can break that down any more than we already have.
Provided as nuts.
Yeah, I got busy
Yet
with
I
work
got busy
again.
with work
Working
again,
overnights
overnights now.
Oh, so you can at least catch me during the day. Unfortunately, since you're working overnights, though, overnights is, you know, where the game time happens, you know?
Provided as nuts. WIM gaming laptop soon now.
What you mean, gaming laptop soon? What, you're gonna take your gaming laptop to work with you? Into the shortest versions of arrow functions.
Provided as nuts.
Can we do anonymous?
Yet I don't do anything but watch movies and TikTok.
Oh, bro, dude, certainly, man. Yeah, that'll be awesome. That would be awesome. Yeah, I used to do security, and I used to do, I used to take care of disabled people. So, I get that. Like, I used to work overnights, just making sure that nobody breaks into their house. So, you know, I'd bring my gaming computer and stuff with me. Okay. How the hell do we turn an anonymous function into an arrow function, though? I guess like that. Yeah? Quanticus, I need you to answer that question. Can you have an anonymous function as an arrow? But it would be my honor to play Smite with you again, Nuts. You're like one of the only people I know that like to play Smite.
Quanticus. Yes, but if it's immediately executing, you'll still need, at the end.
It didn't like that. Yeah. It doesn't like it. I don't think we need it to be immediately executing.
Quanticus. More.
More. More, Dan?
Provided as nuts. That's only cause I'm too lazy to make the switch to PC. Face with Tears of Joy.
Only because I'm too lazy to make the switch to PC. I mean, you could always get a pre-built. You don't gotta build it yourself.
The arrow function needs to be inside, and then, at the end.
The arrow okay, hold up. So the arrow function needs to be wrapped inside. Okay. You got it. Yeah! We did it! We did it! And the only one I needed to ask a question for was that one at the end. But again, that's something that I'm not used to, so that's understandable. I'm only going to beat myself up on stuff that I should know. Stuff that I haven't practiced, I'm not going to beat myself up over. I mean, technically, dude, if you wanted to go a pretty fair route, like price-wise, get a Legion. Get a Legion Go.
That's what I'm going to do, but
best couple $100 I've ever spent. Seriously. Best couple $100 I've ever spent was a Legion Go.
Quanticus.
It played everything.
Oh boy, recursion, prepare for brain melt.
No. No, you know it's bad when Quanticus says that my brain's gonna melt. I don't know, we might be cutting today's stream short. I really didn't want to have to, but the wife is going to be going on lunch probably soon. Recursive functions. There is one more topic we need to cover, recursion. A recursive function is a function that calls itself within its code using recursive algorithms. Certain problems can be solved quite easily. Writing a function that just simply calls itself inside of its code will create an infinite loop. That's why we need to have some condition. You should always make the function call itself inside of an if statement or something similar that includes decision making. Recursive functions are a bit more complicated and take some time to get used to. Always use them with caution. Any problem that can be solved with recursion could also be solved with some kind of loops and iterations. This is what looping through an array might look like with a recursive function. So our function is recursive loop. Our args are array and index equals 0. And in our curly brackets, if index absolutely equals array.length, then return console log array's index. Recursive loop then gets called within itself with the arguments array index plus 1. Wow. That is something. And then it loops again, huh? Const array equals 25156. And then we call recursive loop array down here, which outputs 25156. Holy crap. The first time the function is called, we pass in an array. The default value for the index is 0 at the time. We start running the code inside. The index 0 is not the same as the array's length. So, we log the element at that index, then we call the same function with the same array, but we add 1 to the index. This keeps happening until the index goes out of bounds, aka becoming equal to the array's length. We check if index absolutely equals arrays.length because indexes are 0 based, so the last index of the array is array.length minus 1. So if the index this is like the third typo I've seen, and my brain just fumbles every time. So if the index has reached our array.length, it means it has gone out of bounds. Recursive functions are a good thing to be familiar with, even though you might not use them very often. Alright. So our challenge is write the code for the function factorial that calculates the factorial of a number. If we don't know what factorial is, factorial means the product of the number and all of the numbers below it. For example, 5 factorial would be 5 times 4 times 3 times 2 times 1 equals 120. Use recursion. Your function should return the value. No need to print it. Return values are tested automatically. Wow. Alright, let's get that prepped in our compiler. Okay. And our first arg is 5. Alright. For example, 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay. So if, if number do we need an index of some sort? Alright, I can do this.
Quanticus. There's no array this time, so what do you do? Dun dun dun.
Right. I got so used to it. Okay, alright. There's no array this time, so what do you do? Dun dun dun. Alright. So we have a number, which is going to be 5. So we need to count equals 0. If count is less than number, okay, hold up. The brain is processing something here. So in our example, we'll go back to that. So function recursive loop, array and index equals 0. So we declared index in our arguments there. Yeah. Okay. If index equals array.length, then return console log array index. And recursive loop array index plus 1.
Quanticus. The if check to terminate the recursive loop is called the base case. So what do you check to see if you need to stop the recursion?
Number. Right? We need to check if our count
Quanticus. Right.
equals number. Oh man, like it does this all kinds of wonky. So we don't use curlies here. Wow. return. I don't like how we're changing functions all up like this.
Quanticus. Since count is always 0, you can just hard code the 0 into the if, instead of declaring a variable.
Okay, explain that one to me. Since count is always 0, you can just hard code the 0 into the if. Are you saying that we don't have to do let count equals 0, that we could just let count, just declare the variable itself? No, instead of declaring. If number equals 0. Okay. Okay. If how I was doing it, like if I would have proceeded that route, would it technically have been wrong? If number does equal 0, then console log
Quanticus. It would have
worked,
but
have been slightly inefficient but unnoticeable. Gotcha. Thank you for that. Okay, so if number equals 0, return this. Console log, I'm guessing number, yeah? And then call factorial. Number plus 1. So that should do 5. Oh, okay, nope. Infinite loop. We are infinite loopy time.
Quanticus. This time you don't just return nothing, you will have to provide a value.
This time you don't just return nothing, you will have to provide a value.
Quanticus.
You're starting with number and going down. My brain absolutely farting here. Oh. Going down. Okay, 5 times 4 times 3 times 2 times 1. Five, 4, 3, 2, 1. Okay, we're getting closer. So we're counting down now, but we need to be times. So number times number. Minus, okay, nope. That wasn't right. That wasn't right. Alright. That was not right. So how can we get... Wait. Number minus 1, which would still... No. That just returned 5. Okay. That wasn't right either.
Quanticus.
Let's look at it from the perspective of the first iteration.
When number equals 5.
So let's look at it from the perspective of the first iteration. When number absolutely equals 5, we're subtracting 1, right? currently in its current state, if the number equals 5, we're counting back. Yeah. Or are we asking for more specific?
Quanticus. You're subtracting 1 to call the recursive function, but what do you do with the 5 you currently have?
Alright, you're subtracting 1 to call the recursive function, but what do you do with the 5 you currently have? Currently nothing. Currently nothing. We need it. So we need the 5 to subtract 1 and multiply it. Oh man, I think this is what you were talking about with the brain melt, because my brain is melting on this math. Okay. You're subtracting 1, all the recurse. Yeah. Yeah, because factorial, our argument is number minus 1. Starts the loop over again. I broke it. Okay. So then, you're starting with number, going down. Let's look at it from this perspective. Number equals 5. You're subtracting 1, call the recursive function. What do you do with the 5 that you currently have? Are we gonna need to create another variable?
Quanticus. So let's say you weren't doing recursion.
Okay.
The function would simply return 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1, but right now you only have access to the 5. So in your recursive function you'll have some variation of 5 asterisk something, right?
Correct. Which the 5 is number, right? So let's say that you weren't doing recursion. The function would simply return 5 times 4 times 3 times 2 times 1. But right now you only have access to the 5. So in your recursive function, you'll have some variation of 5 times something.
Quanticus.
Yeah.
Yes.
5 is number. So number times something. Number times number. Because it's going down by 1 each time, right? No. Yes. Yes. Because 5 times 4 times 3 times 2 times 1. And if it's decrementing by 1 each time, right?
Quanticus.
Number times something that'll give you
1 less than 5.
So number times number minus 1.
Quanticus.
No.
No.
Okay. Still not on nail on the head with that yet. Okay, so we need something. Okay, so I guess my next question, do I need to declare something in order to have a value accessible? If that makes sense.
Quanticus.
You don't need to declare
You
any
don't
new
need
variables.
To declare any new variable.
So it's not number times number minus 1, but it is number times something that will give me 1 less than 5, which number is 5 right now. And I'm guessing this is something that's going to go in either in between line 3 and 6.
Quanticus. It will ultimately
replace line 5. Okay. So it's something to do with here then. This is wrong, pretty much. But it's not number times number minus 1.
Quanticus.
That part is correct. Oh, okay.
Quanticus.
We need to add to the line. Okay. The whole line or just the argument?
Quanticus.
The whole line.
The whole line.
Wow. Okay. So we need to add something to the function call. Wow, this one is breaking me. Full line. Do I feel defeated yet? Is this what defeat feels like now? Factorial. Number -1. But we need...
Quanticus.
If... Okay. Alright, we got more hints.
Equals 0, you return something. If not, then you want to return 5, 4, 3, 2, 1, but you only have the 5 right now.
Okay. If number absolutely equals 0, you return something. If not, then you want to return 5 times 4 times 3 times 2 times 1. But you only have the 5 right now. Is it another... Is it an if-else?
Quanticus.
It's not an if-else. Okay. It is not an if-else. I feel like I'm asking all of the right questions, at least.
Quanticus.
But it is a return statement instead of simply calling them.
The recursive function.
Really? So, like what? Return number times... It's not number times number.
Quanticus. All one line, remember.
All one line. I don't remember. I'm broken. I'm a broken man. All one line. Is it number times number? I feel like I already said this. We do have only access to 5. It's not an array, so it's not an index.
Quanticus.
Not number times number, but your code is practically there as it is. Okay. Return number time. So it is number times something, but it's not number times number, and our code is almost there. Just to confirm, number times something. But it's not number times number.
812 superfat.
Bring the factorial up to the same line and try to explain what's happening. Okay.
Quanticus. Bring the factorial up to the same line and try to explain what's happening.
Like that. Do I take the times out?
Quanticus. Yep, explain it to me like
Explain
I'm a
it
duck.
to you like you're a duck. So we have...
Quanticus.
Don't take
Don't
anything
take
out.
anything
Okay.
out.
Alright. I believe in you. Alright, so function name is factorial. That's taking in a number, which is 5. If number absolutely equals 0, we are returning console.log number. If it does not equal 0, I'm guessing is what's going on here. If it does not equal 0, then we're returning number times our function of number minus 1. Did I explain that right? That's the first step of understanding this, if I can at least explain it right. If I didn't get it right, just say not quite. And if I did get it right, just say yes.
Quanticus.
And that function call will resolve before the return does. You're on the right track. And that function call will resolve before the return does. If number absolutely equals 0, return the number. If it doesn't, then return number times our factorial function with number minus 1. That is crazy. That's craziness. That is some brain stumping power right there. Alright, so we found another thing that definitely I'm going to have to practice. Recursion. If there's anybody that has anything... Just like I stated the other day, if anybody had... What is going on here?
We're not done yet, you need to test the output.
We're not done yet. You need to test the output. 5, 4, 3, 2... Oh. We're supposed to be getting 5 times 4 times 3 times 2 times 1. And we're getting 5, 4, 3, 2, 1. Although, unfortunately, I do have to wrap Quanticus. So I do have to go to my wife for her lunch. I may be back on for like another hour or so when I am done with her lunch, though. So I do have to go on break.
Quanticus.
Enjoy my lunch. Okay, so you might see me again, and then we'll go through this and figure this out. I'm having fun with it, though, but definitely need to learn it.